Okay, so here's one more for you. We're going to prove the property that the number of nodes at depth d in a perfect binary tree is equal to 2 raised to the power of d, and I've quickly drawn out the base case here. Now think about what this question is asking. It's not asking for the total number of nodes. It's asking for the number of nodes at a given level of the tree. So if we use 0 as our base case, at depth 0 we just have our root. So the number of nodes would be equal to 2 raised to the power of 0, which indeed does equal 1. At the next level down, we have level 1, and you can see in the illustration you have 2 nodes. 2 raised to the power of 1 does in fact equal 2, so we can prove our base case. Now, let's assume that for the number of nodes at depth k, we have 2 raised to the power of k holds true. So now we're going to show that the number of nodes at depth k plus 1 equals 2 raised to the power of k plus 1. So here's what we're going to do. We're going to say 2 raised to the power of k plus 1 equals. And now here's the thing. With binary trees, you have to kind of think about the pattern. Now this formula is for a perfect binary tree. And what that means is that for each level we traverse down, so as depth increases, that means that each subsequent level, the number of nodes is going to double. And we know that because each node on any given level has to have 2 children in order for it to be perfect. So if I were going to extend this current tree we have here drawn down another level, I'd have to give him a right child, him a left child, him a right child, him a left child. I'd have to do this for every single node in the tree. My tree got kind of cut off at the edge, but you get the point. So you can see that holds true. So a way we can do this is we can see if 2 to the k plus 1 equals 2 raised to the power of k times 2. What does this say? Well, does however many nodes we get by 2 raised to the power of k plus 1 equal the number of nodes we get by simply doubling 2 raised to the power of k? And the answer is yes, it does. We can simplify this. And all this is saying, if you have something times 2, is it adding by itself. It's the same thing as saying that. And since we know, due to the exponent rule, wherever you add 2 raised to the same power equals 2 raised to that power plus 1, we can say that this is equal to 2 to the k plus 1. And hence we've proven that you can find the number of nodes at any depth d by using this formula. I'm going to stop here. There's a few more properties I can prove, but I'm not going to do them unless people are finding this useful. So if you want to see some more, there's about 2 more binary tree properties that we might get in the exam. I'm happy to walk through them. Let me know.